Imagine standing on the surface of Earth, gazing up at the sky on a clear, moonless night. The stars you see twinkle like pinpoints of light, tiny in comparison to the vastness of the universe. But what if I told you that some of these stars are so immense, so mind-bogglingly large, that if one of them were to replace our sun, it would engulf not only Earth but Mars, Jupiter, and beyond? Yes, we're talking about a star so colossal that it shatters our very understanding of size. Let's journey into the cosmic unknown and explore one of the universe's greatest giants, WOH-G64, the largest star we know of so far. Looking up at the night sky, it's easy to forget how little we're actually seeing. The stars we observe with the naked eye represent only a tiny fraction of what's really out there. Our galaxy, the Milky Way, is home to somewhere between 100 to 400 billion stars. Beyond that, there are billions of other galaxies, each with their own countless stars, planets, and cosmic phenomena. The closest star to us, the Sun, might seem large and blindingly bright, but in the grand scheme of things, it's a mere drop in the ocean. The Sun is classified as a main sequence star, which means it's fairly average in size, mass, and brightness compared to other stars. But make no mistake, there are stars out there that are so massive, they make our sun look like a speck of dust. So, how big can a star get? Let's start by breaking down the factors that define a star size. When we talk about the size of stars, it's essential to distinguish between two key concepts: mass and volume. Mass refers to how much matter a star contains, while volume is the amount of space it takes up. Strangely, the stars with the most mass aren't necessarily the largest in terms of volume, and vice versa. Some of the universe's biggest stars by sheer size are actually quite lightweight, at least in comparison to their massive cousins. As stars age, they often lose some of their mass, which can dramatically affect their size. Our sun, for example, will one day transform into a red giant as it burns through its nuclear fuel. In about 5 billion years, it will swell up, likely consuming Mercury, Venus, and possibly Earth in the process. Scary, right? But even at its most bloated, the Sun will still be dwarfed by the true giants of the cosmos. Let's talk about one such star, known as BAT 99-98. Before we get to WOH-G64, let's give a shout out to BAT 99-98, one of the most massive stars ever discovered. This star is a whopping 226 times the mass of our sun. That's right, 226 suns packed into a single star. How on Earth, or rather, how in space, did it get that massive? Some scientists think BAT 99-98 might have formed from the merger of two stars. Despite its enormous mass, BAT 99-98 isn't the largest star by volume. Its radius is only about 37.5 times that of the Sun, which, while still impressive, is nothing compared to the true titans we'll be discussing. What's even more interesting is that BAT 99-98 is shedding mass at an incredible rate, losing as much as 20 suns worth of material since it formed. It's a ticking time bomb, destined to explode as a supernova, likely leaving behind a black hole. But enough about BAT 99-98. Let's move on to the star of the show, WOH-G64. If you thought BAT 99-98 was massive, wait until you hear about WOH-G64. Located roughly 160,000 light-years away in the Large Magellanic Cloud, a satellite galaxy of the Milky Way, WOH-G64 is a red supergiant with an estimated radius 1,540 times that of the Sun. Let that sink in for a moment. 1,540 suns stacked on top of one another wouldn't even come close to matching the size of this colossal star. If WOH-G64 were to replace the Sun in our solar system, it would stretch far beyond the orbit of Jupiter. Earth, Mars, and every planet up to Jupiter would be swallowed whole by this enormous star. That's a level of gigantism that's hard to wrap your head around. What's even more intriguing is that WOH-G64 is likely nearing the end of its life. Stars like this expand dramatically as they age, puffing up into red supergiants as they exhaust their nuclear fuel. The result is a star that's not just large, it's truly enormous. But WHG-64 isn't just a bloated mass of gas. It's also surrounded by an incredible cloud of dust. WHG-64 is shrouded in a vast cloud of dust, forming a torus, or donut-shaped, ring around the star. This dust cloud spans roughly 1 light-year across, which is a distance so vast that light itself would take a year to travel from one end to the other. The amount of material in this cloud is mind-blowing. Scientists estimate that if you could gather it all, you'd have enough material to create 9 solar systems. However, this dust also makes it difficult for astronomers to measure WHG-64 accurately. The dust blocks much of the star's light, making it tricky to determine its true size. While the current estimate puts the star's radius at 1,540 times that of the Sun, some studies suggest it could be even larger. One measurement placed WHG-64's radius at an astonishing 2,575 times the Sun's, which would make it the largest star ever observed by far. To give you an idea of just how big WHG-64 really is, let's do a thought experiment. Imagine you could travel around WHG-64 at the speed of light. How long do you think it would take? For comparison, if you traveled around our Sun at light speed, it would take you about 14.5 seconds to complete one lap. But with WHG-64, the same journey would take over 10 hours. This gives you an idea of just how colossal WHG-64 is. It's not just big, it's incomprehensibly big. You might be wondering why scientists don't have a more precise measurement of WHG-64. After all, we've got telescopes that can see billions of light years into space. The problem is that stars are complicated beasts. They don't have solid surfaces like planets, and their outer layers are often made up of diffuse gas that can stretch for millions of miles. Throw in factors like distance, dust clouds, and fluctuating brightness, and you've got a recipe for confusion. Measuring the exact size of a star like WHG-64 is tricky business. But thanks to ongoing advancements in technology and observational techniques, we're getting better at it all the time. While WHG-64 currently holds the title of the largest known star, it's unlikely to keep that title forever. The universe is vast, and we've only explored a tiny fraction of it. As our technology improves and we learn more about the cosmos, it's entirely possible that we'll discover even larger stars hiding in the far reaches of space. And even if WHG-64 remains the largest star we've found, it won't be around forever. Like all stars, WHG-64 will eventually burn through its nuclear fuel and collapse, likely ending its life in a spectacular supernova explosion. What happens after that is anyone's guess. Will it become a black hole? Or perhaps something even more exotic? One thing's for sure, the universe never ceases to amaze. From stars like BAT 99-98, with its incredible mass, to WHG-64, with its near unimaginable size, the cosmos is full of wonders that challenge our understanding of the very nature of existence. As we continue to explore and learn more about these colossal stars, who knows what other secrets the universe has in store for us? So, next time you look up at the night sky and see those tiny points of light, remember that some of them are so massive, so huge, that they make our sun look like a grain of sand in an endless desert. The universe is vast, mysterious, and awe-inspiring, and we've only just begun to scratch the surface of its wonders. Keep looking up and never stop wondering. If you enjoyed this video, don't forget to hit that like button, share it with your friends, and subscribe to the channel. And of course, tap that bell icon so you never miss out on any of our cosmic adventures. Thanks for watching, and I'll see you in the next video.